Okay, so in this section, we're going to cover 4.1. The title of section 4.1 is the mole concept and atoms. And there's really two types of problems that are covered in this chapter. We're really only going to cover one of those two. So if you'll notice here, I have examples 4.4 and 4.5 up on the screen. That's the type of problem we're going to cover. There's a second type of problem involving conversions between numbers of atoms and grams. And, well, that's a different topic. Okay, so let's take a look at example 4.4. It says, what is the mass in grams of 3.01 moles of sulfur? So let's remind ourselves that in the periodic table, we have a lot of useful information. So when we look up sulfur, we have two numbers. One at the top, remember that's the atomic number. That's the number of protons in the atom. Or if you're doing electronic structures, it would also be the number of electrons in the structure, in the atom. But we have this other number down here that is what we're going to focus on. So this is 32.06. And this is what's called the atomic mass, which has the units of AMU, atomic mass units, but it's also what we call the molar mass. And that has the units of grams divided by moles. And that's what we're going to use right here. Okay. So when you read out these questions, if it says, hey, we want to know the mass and it's in grams, G for grams, and there's moles in there, you want to use the molar mass. Okay. If it asks you for, what is the atomic mass in AMU, then you would call that atomic mass in AMU. But the key to this is that you've got mass, grams, and moles. So that's why we're using this one down here. Now, here's what that information says. Think of a mole as the analogy to 12, a dozen, right? 1 dozen is 12. The mole is kind of the same idea. It's just a bigger number. It's 6 times 10 to the 23rd. Okay, I wrote it the opposite there. I put the number on the left and the unit on the right, whereas with dozen, I put the number on the right and the unit on the left, but that's the same idea. Okay, so a mole is 6 times 10 to the 23rd atoms. But there's also a relationship here. What this means, the meaning of this piece of information, this number here, 32.06, is that 1 mole of sulfur is 6 times 10 to the 23rd atoms of sulfur. S for sulfur. I'm just going to write S for sulfur. We'll use the symbol. Saves a lot of space and time. That has a mass of 32.06 grams. G for grams, right? Mass is going to be in grams for these problems. So there are 3 numbers associated with that one number, but you have to intuit that. It doesn't explicitly say in the periodic table that 1 mole of sulfur is 32.06 grams. But that number, 32.06, means 32.06 grams of sulfur equals 1 mole of sulfur. Okay? Then we use that as a conversion. And so the way that's done is we take the number 3.01 moles of sulfur, and we use this conversion here as a conversion factor. I'm going to write it up here on the right side. 1 mole of sulfur is 32.06 grams of sulfur. This can be written in 2 ways. We can either write the mole on top and the grams on the bottom, or we can write the grams on top and the moles on bottom. Those are just reciprocals of each other, right? So now what do? We look at what we're given. We're given the moles and we're asked for the grams. This is what we're asked for. Okay, this is given. So we pick the one of these 2 conversions that will give us the correct units. So I'm going to multiply this by I'm going to put grams on top, 32.06 grams over 1 mole of sulfur. Putting this one right here, grams on top, moles on the bottom. Why? Because look what happens. Moles of sulfur divided by moles of sulfur is 1, and that just leaves us with grams of sulfur, okay? If you need to watch that, a couple of times, go ahead and watch it a couple of times. But that's essentially what we're doing. So now 3.01 times 32.06. Technically, you then divide it by 1. There's a 1 down there, so technically you divide it by 1. But we all know that dividing by 1 is going to give you the same number. Sorry. So what does that give you? That gives you 96.5 grams. Okay, and that tells us that if we have a little more than 3 moles of sulfur, it'll weigh a little more than 96 grams, between 96 and 97 grams. Okay, so again, watch that again if you need to. You take this number here, which is the molar mass, that number of grams equals 1 mole. So I wrote that up here on the right side so you can see it separately. You take this, put it on the top, put this one on the bottom, do the other one too. Put this on the top and this one on the bottom, and then pick the one that's going to give you the units that you want. Keeping in mind that if you start with grams and you put moles over grams, the grams will cancel. If you start with moles and you put grams over mole, the moles will cancel, right? And that gives you grams. This one will give you moles. So let's try the reverse. The second one, example 4.5, does the opposite of that, okay? So they're giving us a little trick here. It's a kilogram of sulfur. Okay, that's a little trick because we want to have it in grams. So what I'm going to do is remind myself kilos 1,000 or 10 to the 3. So that's 1.00 times 10 to the 3 grams of sulfur. Remember, that comes back from the earlier part of the course. Kilos 1,000, 10 to the 3. Okay, now it's still sulfur. So we get to use the same molar mass. See what's going to happen now? Now we're given the mass and we're asked for the moles. So that's the opposite of what we did in the previous problem. In the previous one, we were given the moles and asked for the mass. Now we're given the mass and asked for the moles. So again, you take your measurement, 1,000 grams, okay? 1.00 times 10 to the 3 grams of sulfur. Pick the conversion factor you need. We want to have moles. So look what happens. If I pick this first one on the left, look what's going to happen. Grams will cancel and you'll get moles of sulfur. Okay, so 1 times 10 to the 3 divided by 32.06 times 1, right? Times 1 divided by 32.06. You can ignore the 1. And you get 31.2 moles of sulfur. There's your answer. Okay. First one, we get grams of sulfur. Second one, we get moles of sulfur, right? So 1,000 grams is a lot. 1 mole is 32. Think of it this way. If 1 mole is 32 grams, I'm just estimating, then 10 moles would be 320 grams, right? But you have 10 times as much, you have 10 times as much. If I have 20 moles, that'd be twice as much as 10, so you'd have 640. If I had 30 moles, well, that would just go up by another 3, right? You take 10 times 3 is 30, you get 960. Look what you have here. 30 moles is about 960 grams. Well, we have 1,000 grams. A kilogram is 1,000 grams. So we have a little bit more than that. So maybe add 1 more mole, right? 31 moles. So add 1 mole. 1 mole is 32 grams. So 30 moles plus 1 mole is 31 moles. So that would be 960 grams plus 32 grams. No, I'm rounding. It's 32.06, obviously. I'm rounding these numbers, but I'm just trying to show you that that would come out to about 992 grams. So if we had 31 moles, that would give us almost 1,000 grams, 992. That's pretty close, right? If I said you owe me $1,000, you gave me 992, I would probably be okay with that. You're pretty close, right? Same thing here. 31 moles is 992. 31.2 moles is 1,000, a little bit more than that. Okay. So like I said, if you want to watch this video again, try it. Your textbook also gives an explanation for how to do this problem, these two problems. So try them again. So read it, watch the video if you want. Try the problems, try these on your own. Make sure you see how you're doing it, what the reasoning is. Why are we dividing by the 32.06 as opposed to multiplying by the 32.06? And be sure you have access to a periodic table next to you. Just open it up on your phone, just get a periodic table off the internet, have one near you. Your textbook also has one. Sometimes it's a little hard to find it in there, but get a periodic table. Do this on paper. Okay, do the calculations on paper, do these two problems over. And then once you're done with these, then you can do the end of chapter problems.